Correcting problems in the data. In the previous chapter, we have learned on how to spot outliers. So this time, we will discuss on how to deal with them. One way of dealing outliers is to transform the data. What are the ways on how to transform the data? Number one is logarithm transformation, or log x sub I. X sub I here is any number in the data set. So taking the logarithm of a set of numbers squashes the right tail of the distribution. As such, it's a good way to reduce positive skew. However, you can't get a log value of 0 or negative numbers. So if your data tend to have 0 or produce negative numbers, you need to add a constant to all of the data before you do the transformation. For example, if you have zeros in the data, then do log x sub I plus 1. Or if you have negative numbers, add whatever value makes the smallest number in the dataset positive. The logarithm transformation can correct positive skew and unequal variances. The second type of data transformation is square root transformation, or square root x sub I. Taking the square root of large values has more of an effect than taking the square root of small values. Consequently, taking the square root of each of your scores will bring any large scores closer to the center, rather like the log transformation. As such, this can be a useful way to reduce positive skew. However, you still have the same problem with negative numbers. Why? Because negative numbers don't have a square root. So square root transformation can correct positive skew and unequal variances. The third type of data transformation is reciprocal transformation, or that is 1 divided by x sub I. Dividing 1 by each score also reduces the impact of large scores. The transform variable will have a lower limit of 0. One thing to bear in mind with this transformation is that it reverses the scores. Scores that were originally large in the dataset become small after the transformation, but scores that were originally small will become big after the transformation. For example, imagine two scores of 1 and 10. After the transformation, they become 1 divided by 1 is equal to 1. And 1 divided by 10 is equal to 0.1. The small score becomes bigger than the large score after the transformation. However, we can avoid this by reversing the scores before the transformation. How? By finding the highest score and changing each score to the highest score minus the score you're looking at. So, you do a transformation 1 divided by x highest minus x sub I. Reciprocal transformation can correct positive skew and unequal variances. The last type of data transformation is reverse score transformation. Any one of the above transformations can be used to correct negatively skewed data. But first, you have to reverse the scores. To do this, subtract each score from the highest score obtained, or the highest score plus 1, depending on whether you want the lowest score to be 0 or 1. If you do this, don't forget to reverse the scores back afterwards, or to remember that the interpretation of the variable is reversed, meaning big scores have become small and small scores have become big. Reverse score transformations can correct negative skew. So how to transform the data using SPSS. But before that, let us first familiarize the compute function. The parts of the compute function. On the upper right corner is the command area. This one. Below the command area is the function group. There you can see the categories of functions, and below is the functions and special variables. On the upper left corner is the target variable box, And then below is the type and label. Below it is the variable lists, this one. And at the center is the description of selected function. We will apply those 4 types of transformation using download festival save data. This one. So we'll solve the logarithm for day 1. So the first step is simply click transform, then click compute variable, then in the target variable box, you type in log day 1, and then click type and label, and then write log transform hygiene scores for day 1 of download festival. And then click continue. Go to the function group, click on arithmetic, and in the box labeled functions and special variables, click on LG10, that is log transformation to base 10. And transfer it to the command area as LG10 question mark. Click on the arrow. Replace the question mark with the variable day 1 by either selecting the variable in the lists and drag it across by clicking arrow. This one, and then click arrow, or simply type day 1 and click OK. Let us go back to the data view. So there you have it. So this is the log transform hygiene scores for day 1 of download festival. This time, let us solve for the logarithm of hygiene scores for day 2. For the day 2 hygiene scores, there is a value of 0 in the original data, and there is no logarithm of the value 0. So to overcome this, we should add a constant to our original scores before we can take the log of those scores. So any constant will do, provided that it makes all the scores greater than 0. So in this case, our lowest score is 0 in the data set. So we can simply add 1 to all of the scores, and that will ensure that all scores are greater than 0. How? The same process, click transform, click compute variable, reset. In the target variable box, you type in log day 2. Then click type and label. Then you type in log transformed hygiene scores for day 2 of download festival. Then click continue. Then in the function group, you click arithmetic, click LG10, then click the arrow, replace the question mark with variable day 2. Click day 2, transfer by clicking the arrow, then you click the plus sign, then click 1. Then click OK. Let's go back to the data view. Now this time, we will solve for the square root of day 1. So the same process, click transform, click compute variable, reset first, and then you type in sqrt day 1. Then click type and label. Then type in sqrt transformed hygiene scores for day 1 of download festival. Then click continue. Then in the function group, you click arithmetic, and in the box labeled functions and special variables, click on sqrt. And drag it to the command area or click on the arrow. In the command area, it appears as sqrt question mark. Replace the question mark with variable day 1 by typing or clicking on the arrow. We can type day 1. Then click OK. Let's go back to the data view. So these are the answers. The square root for day 1. This time, let us solve for the reciprocal transformation of day 1 scores. So first step, click transform, click compute variable, reset. In the target variable box, you type in RIP day 1 and then click on 1, and then slash, or that is the sign for division. Then select the variable name that you want to transform from the lists and drag it across. So we will use hygiene scores day 1 of download festival. Click on the arrow and then click OK. Then let's go back to the data view. So this is now the answers. This time, let us plot the histogram for logarithm of day 2. Just click on graphs Then click Chart Builder, and then choose histogram. Drag the histogram here, and then click Log Transform Height and Scores for Day 2 of Download Festival in the X-axis, and then click Mark Check the Display Normal Curve, and then click OK. Now, let's go back to the PowerPoint presentation. So I have here the histograms between the untransformed data and the transformed data. As you can see, it is very evident that the skewness after the transformation is reduced. The same with the other datas.